Ahead, in this edition of The Human Body, we'll take a look at the dramatic and efficient digestive system. You'll learn how this remarkably effective mechanism turns food into life-sustaining energy. You'll find out how your brain lets your body know you're hungry and alerts you when you're full. Also, why do some foods taste so good and others don't? Learn what role taste buds play in digestion. You'll get detailed explanations of how different organs in your body's digestive system work. You'll also hear from leading researchers and physicians about contributing factors in weight gain, nutrition, and even disease that can all be traced back to the food we eat and the way our bodies digest this fuel. Get ready for an adventure through your incredibly complex digestive system. It's your personal power plant. This resource recovery facility is recognized as a model for modern recycling. We chose this plant as the backdrop for this program because, like your digestive system, this facility is a highly integrated operation designed for generating energy. Hello, I am Mike Dowling, and I am your host for The Human Body. The fact is, energy is the key to human life. Everything you do requires it. Whether you choose to go inline skating, play football, or read a book, you've got to have energy. Everything your body and mind do is sustained by the energy derived from your personal power plant, your digestive system. And where does this energy come from? Ross Joel reports.
The corner market, the local vegetable stand, a carton of milk, a loaf of bread. It all seems so simple, buying groceries, and it is. But take that food home and prepare your next meal. And give some thought to how complex a system is required to change that sandwich into vital food energy. Food is the fuel that gives your body the energy it needs to work and play. Food energy is a necessity, whether your job includes heavy lifting or intense thinking. The body is also able to grow larger and stronger because of the raw materials it gets from food. Food also allows you to repair damaged tissues and produce new cells.
When we think of food in relationship to its contributions to our physical and mental well-being, we're looking at food as the foundation of life. You wouldn't be able to exist without it. If you think of your body in terms of a car, if you didn't put gas in your car, it wouldn't go, and it works much the same way with food. If you did not eat food and use food, there's no way you'd be able to function.
Resource recovery plants operate much like your digestive system. The facility takes in solids, in this case waste, and ultimately turns it into energy. Your body's digestive system does the same thing with food. It takes in material in one end, quite literally food into your mouth, and sends byproducts out the other end in the form of energy for life.
It consists of a number of different components. The first is the mouth for chewing or destruction of the food into small pieces. Salivary glands which lubricate the food and provide some digestive enzymes to help initiate the process of digestion. And then the esophagus, or the humble organ, which takes the food into the stomach, which is nothing more than an acid bath to kill all the bacteria that you swallow, and also provide some signals to the rest of the digestive tract to tell them the food is on its way down.
Your body is your own personal power plant, and it functions much like this facility. This plant takes in one form of energy and changes it into different, more efficient energy forms. With resource recovery, power plants like this one reduce the size of garbage by removing non-combustible materials like glass and grit. The result, the remaining waste burns faster and hotter. Therefore, the energy output is greater for the communities that the plant serves. Your body also consumes energy in the form of food. Like a power plant, your body's digestive plant burns some foods more efficiently than others. It also gets rid of unused or unburned food energy in the form of waste.
The digestive system is simple in the sense that it takes food into the body and it secretes waste products. And it does that in a sense that is very general. It's very complex in that it takes in food and nutrients, and it helps to separate what is usable and what is non-usable by the body.
Food that you consume at the dinner table can't be used by the body right away. It takes time to process or digest that raw material before it becomes a source of energy. And processing it means that the body has to break the food down and change it into other forms. This change is created by a group of organs that together form the human digestive system. Ross Joel reporting. Now let's do a quick review. Energy is your key to life. It sustains your body in all of its processes. Your body uses food as the fuel it needs to create energy. The food you eat is actually converted into energy, enabling you to grow tissue, repair damaged tissue, and produce new cells. Your body has a digestive system, which aids the body in creating the fuel it needs to survive. Your digestive system does this by actually converting food into energy. Before food can be converted, it must be broken down or digested. The digestive system is an open system, or a system that literally has two openings. One allows the intake of food, the other the excretion of wastes.
Imagine this, 30 feet of tubing wrapped up tightly inside your stomach. I guess that's a little bit like swallowing this garden hose, but don't worry, we're not going to ask you to perform any circus-like act. In fact, you've already done it. Your digestive tract is nearly 30 feet in length. This long continuous tube is called your gastrointestinal tract or your GI tract. The organs that compose the GI tract are the mouth, pharynx, esophagus, stomach, small intestine, and large intestine. The GI tract contains the food from the time it is eaten until it is digested and prepared for elimination. Accessory structures are the teeth, tongue, salivary glands, liver, gallbladder, and pancreas. All accessory structures, except for the teeth and tongue, lie totally outside the tract and produce or store secretions that aid in the chemical breakdown of food. When you eat, it is the hypothalamus of your brain which acts as the control center for food intake. It has both an appetite and satiety center comprised of clusters of nerves.
A low blood glucose level or a low blood sugar would really stimulate hunger because what the body's telling you is that I need food to function. On the other end of that, after you finish a meal, your blood glucose level goes up. And your body has a whole system of hormones to help bring it back down. At that point, you're not going to be hungry.
We all know what it's like to experience an incredible smell, like cookies or bread baking, maybe even chocolate in a candy store or a hamburger on a grill. Well, those aromas can literally be mouth-wateringly good. The saliva that you excrete when your mouth waters ultimately adds enzymes to the food you eat. Those enzymes, combined with chewing, help break down food into a usable form. As Kim Clay explains, it's all just the start of turning food into energy.
A child playing with building blocks. In a simple way, it's reflective of the 5 elements involved in digestion. Take I for ingestion. It's the voluntary action of placing food in your mouth. D for digestion, the breakdown of food by both chemical and mechanical processes. P for peristalsis, the movement of food along the digestive tract. A for absorption, the passage of digested food from the digestive tract into the cardiovascular and lymphatic system for distribution to cells. And finally, another D for defecation, the elimination of indigestible substances from the body. These building blocks break down in 2 ways, physically and enzymatically.
Enzymes, in essence, are proteins that help break down food products so that the body can digest it. And the digestive process starts right when food is placed into the mouth, so that the chewing process, along with enzymes that are located within the saliva, actually start the digestive process as soon as food is placed into the mouth.
Eating pizza or even peanut butter and jelly tastes good to you because of your tongue. As you chew, taste receptors or taste buds on your tongue make chewing and eating a more pleasant experience. At the same time you're chewing, 3 pairs of salivary glands empty their secretions into your mouth. These secretions are a mixture of mucus and serous fluids known as saliva. You are looking at 5 cups or 40 ounces of water. In the course of one day, your body's 3 salivary glands produce almost this much saliva for digestion. That saliva helps food descend through your pharynx or throat, which is divided into 3 parts. When you exercise, you may sometimes breathe through your nose. When you do so, you are utilizing your nasopharynx, which is part of your respiratory system. Digestion is dependent on the oropharynx, which is at the end of the mouth, and the laryngopharynx, which leads to the esophagus.
The esophagus is basically a tube that connects the mouth to the stomach. So it's just a tube through which food travels.
The esophagus is approximately 10 inches long and conducts food to the stomach via wave-like contractions called peristalsis. Peristalsis is the body's major means of propelling food through the digestive system. Because food is only in the pharynx and esophagus for 10 seconds, no major absorption or digestion occurs there. It's in the stomach where the real intricacies of turning food into energy begin. I'm Kim Clay reporting.
Your digestive tract is also known as your gastrointestinal tract, or GI tract. It extends from the mouth to the anus. Organs of the digestive tract include the mouth, pharynx, esophagus, stomach, small intestine, and large intestine. Other accessory structures aid in the chemical breakdown of food. Your brain is involved in digestion too. In the hypothalamus, clusters of nerves help control your food intake. Chewing and saliva aid in the breakdown of food. Saliva adds enzymes to food, helping to break it down into a usable form. Digestion is also dependent on the oropharynx, laryngopharynx, and esophagus. These structures help move food to the stomach. Remember, the 5 elements of the digestive process are ingestion, peristalsis, digestion, absorption, and defecation.
The stomach is a remarkable organ. It's located on the left side of the abdominal cavity. It is a C-shaped organ, nearly hidden by the liver and the diaphragm. Like the esophagus, the stomach is approximately 10 inches long, but its diameter, like that of this balloon, depends on how much food, or in the case of the balloon, how much air it contains. When full, it can hold about 1 gallon of food. When empty, it collapses inward on itself, much like a deflated balloon. In essence, the stomach acts as a temporary storage tank for food, as well as a site for food breakdown. The muscle arrangement of the stomach allows it to churn, mix, and pummel food, as well as get it moving along the GI tract. These actions break down food into even smaller fragments and mix it together with enzymes. In addition, the gastric glands secrete gastric juice and hydrochloric acid, which help break down protein and kill germs. Take a look at your car battery if you're interested in the acidity of your stomach. Your stomach's pH, or acidity, is approximately 2. That's nearly as concentrated as the sulfuric acid in your car battery. It's strong enough to burn holes in your clothes. It's certainly potent enough to dissolve vitamins and minerals, as well as sugar, which then go directly into your blood. Like the cement inside a mixer, the food inside the stomach is broken down and processed until it becomes chyme, which is a substance that resembles heavy cream. The chyme leaves the mixing action of the stomach via the pyloric sphincter. The emptying rate of the stomach chyme depends on the strength of the stomach's peristaltic wave. The continued wave keeps the gastric opening cleared, and as the waves get stronger, they mix chyme and push the contents toward the pyloric sphincter en route to the small intestine. There are a number of factors that slow the rate of the emptying of the stomach. These include a high volume of chyme already in the small intestine, a very acidic pH in the small intestine, and a high volume of fat in the small intestine. The small intestine is critical to the performance of your body. As Pat Laurie tells us, the small intestine is the place where nearly all food absorption occurs.
Students at the Yale University Medical School have heard many lectures about the small intestine. Some of these students will become physicians specializing in the surgical and medical treatment of disorders of the GI tract, including the small intestine. It is a critically important specialty, given the importance of the convoluted tube, which extends from the pyloric sphincter to the ileocecal valve.
The ileocecal valve is a valve that's located right at the end of the small intestine, and in essence is an opening that leads from the small intestine to the large intestine.
The small intestine is divided into 3 sectors, which are distinguished by the location in which substances are absorbed. These sectors are 1. The duodenum, where the absorption of iron and calcium are most active. 2nd, the jejunum, where the complete absorption of proteins and carbohydrates takes place. And finally, the ileum, where the absorption of fats, bile salts, and vitamin B12 occurs.
Chemical digestion of food is where chemicals such as enzymes begin to break down food into its more simplistic components so it can be used for nutrition for the body.
The small intestine is only able to process a small amount of food at a time. The pyloric sphincter controls food movement into the small intestine from the stomach, preventing it from becoming overwhelmed. The small intestine is vital for the processing of food. It puts more enzymes into food, enabling solids to break down further until its particles are small enough to go into the blood. Your blood then carries these food particles to all parts of your body. Because of this, it requires a great deal of space to carry out its functions. Now, in order to accomplish this, the small intestine is able to increase its surface area by about 600 times. In fact, the surface area of this house is measured at 2,700 square feet. That's the same square footage as the surface area of the small intestine. Like moving through the rooms in a house, enzymes produced by the pancreas and bile from the liver pass through the pancreatic duct and bile duct and into the duodenum and then into the small intestine. This completes the chemical breakdown of food. But how does your 18-foot-long small intestine expand to the area of a small house?
The small intestine is really a long, very long tube. And if the tube were to be flat, the surface area of the tube wouldn't be that much. But what happens is the small intestine is in essence squished into a shorter tube, and because of that, there are a whole bunch of redundant folds along the small intestine, and those redundant folds are known as villi. And the villi then, in essence, allows the small intestine to increase its surface area and thereby be able to absorb more nutrients.
Your small intestine contains millions of tiny villi. There are also millions more ultrafine microvilli that exist, which cover the villi, giving the lining of the small intestine its brush-like appearance. In addition to villi and microvilli, the small intestine also has circular folds which increase its absorptive surface. In fact, the small intestine is sponge-like. It has so much surface area that it can absorb 9 quarts of liquid per day. It may be called the small intestine, but it's clear that it has an enormous role in your digestive system's power plant.
As you'll recall, your stomach is located on the left side of your abdominal cavity. It acts as a temporary storage tank for food. Your stomach breaks down food through churning, mixing, and pummeling actions. Your stomach also secretes gastric juices and hydrochloric acid, which break down proteins and kill germs. When food has been completely broken down by the stomach, it is called chyme. Chyme moves from the stomach through the pyloric sphincter and into the small intestine. Your small intestine is divided into 3 parts, the duodenum, jejunum, and ileum. These parts prepare chyme to move into the cells of your body. Most food absorption occurs in the small intestine. The small intestine is a major digestive organ. Structures known as villi, microvilli, and circular folds help it to increase its surface area by almost 600 times.
It's clear that the small intestine is the most important fixture in your digestive system, but it does not work independently. The fact is, enzymes are necessary to break down food in the small intestine. The secretions produced by the small intestine come in the form of intestinal mucus, but the small intestine does not contain any enzymes. For enzymes, it turns to the pancreas. The pancreas is a soft pink triangular gland that extends across the abdomen from the spleen to the duodenum. Pancreatic enzymes ultimately do not break down all foods. The remaining or undigested food residue in the intestine contains huge numbers of bacteria. That bacteria must be prevented from entering the bloodstream if at all possible. That responsibility belongs to the lymphatic tissue found in the submucosa, or connective tissue, found near the end of the small intestine. It works to cleanse the digestive system of impurities. The system works much like this resource recovery facility. Before garbage is converted to energy, it has to be sorted into solids that will burn and those that won't. The garbage moves through separators where glass, dirt, metals, and other non-combustible materials are removed. It's just like the way your body separates starches, fats, and proteins into those it can and cannot digest. The liver plays a huge role in this cleansing of impurities. It's located under the diaphragm toward the right side of the body. It almost completely covers the stomach. It weighs between 3 and 4 pounds, is 4 to 8 inches across, and is protected from injury by the lower rib cage and sternum. It is one of the most versatile organs in the body. Its role in digestion is the production of a yellow-green watery solution called bile. Bile contains bile salts, bile pigments, cholesterol, phospholipids, and a range of electrolytes. Bile salts act to emulsify or break down large molecules of fat into smaller droplets called micelles, which can be better absorbed by the body. Newly absorbed nutrients are also collected in the liver in the form of glycogen, fats, and proteins, which it stores or turns into glucose.
In essence, the main function of the liver is that it acts as a filter for the waste products of the body's bloodstream. As blood passes through the liver in essence filters out all the waste products of the bloodstream. It uses a lot of its chemicals and enzymes that it produces in order to do this.
When food digestion is not occurring, bile backs up in the cystic duct and enters the gallbladder to be stored. The gallbladder is a small green sac that is embedded in the surface of the liver. While in the gallbladder, bile becomes concentrated by the removal of water. Later, when fatty food enters the duodenum, a hormonal stimulus prompts the gallbladder to contract, forcing bile into the duodenum. The bile then assists in digestion. Strictly speaking, the liver, gallbladder, and pancreas are not organs of digestion, but the roles they play in cleansing the body of poisons and producing hormones and enzymes that are essential for digestion make them key players. Actually, the liver is the only organ of the digestive system that the body must have to survive. In your body, food that cannot be absorbed by your small intestine must be disposed of as waste. In your digestive system, the large intestine's primary function is eliminating undigested food residues, mucus, bacteria, and enough water to allow their smooth passage. The large intestine is about 5 feet long, extending from the ileocecal valve to the anus. Its major functions are to dry out any indigestible food residue by absorbing water and to eliminate these residues from the body as feces. The large intestine frames the small intestine on 3 sides, and it is broken down into the following subdivisions. First, the cecum, the portion of the large intestine from which the appendix opens. Secondly, the appendix. Although it has no known digestive function, it is still sometimes classified as an organ of the digestive system, primarily because of its location just behind the cecum. Only 3 to 4 inches long, the worm-like appendix hangs from the cecum and is a potential trouble spot. It has an extremely twisted formation and is an ideal location for bacteria to accumulate and multiply. Inflammation of the appendix or appendicitis can be the result. The colon is the 3rd subdivision of the large intestine. It is the longest part of the large intestine and is named for the Greek word for limb. The colon has 4 parts, which include the ascending colon, the transverse colon, the descending colon, and the sigmoid colon. Rectum is the Greek word for straight, and this 4th portion of the large intestine makes up the final 7 to 10 inches of the intestinal tube. The last inch of the rectum, or the anal canal, is the 5th and final component of the large intestine. Because most nutrient absorption has been done before the large intestine is reached, no villi are seen there. There are, however, a large number of goblet cells that produce mucus. The mucus acts as a lubricant to ease the passage of feces to the end of the digestive tract. It is the defecation reflex that actually gets the material out of our bodies. The reflex is stimulated by stretch receptors, which stimulate the rectum to contract and void the waste materials.
Your small intestine is certainly an important part of the digestive process, but it does not work alone. It needs enzymes to help do its job, and it receives them from the pancreas. The pancreas monitors and produces 2 vital hormones, insulin and glucagon. It also secretes substances directly to the small intestine, which are critical for the digestion and absorption of food. Food that is not completely broken down in the intestines is laden with bacteria. It is your lymphatic tissue that works to prevent this bacteria from entering your bloodstream. The liver also plays a huge role in cleansing impurities, and it is the one organ that the digestive system must have to survive. The liver secretes bile, which breaks down large molecules of fat. Your gallbladder stores this bile when it's not being used. The large intestine makes up the final portion of the digestive tract. Its primary functions are the absorption of water and the elimination of waste. The large intestine is divided into 4 sections: the cecum, appendix, colon, and rectum.
So now you understand how the digestive system processes food, but how does it utilize food for energy? We've told you how a resource recovery plant burns combustible waste and turns it into energy. Well, your body does the same thing. You've heard the expression, you are what you eat? Well, it really is true. The body uses food as metabolic fuel. That energy is measured in units called kilocalories, which are meticulously counted by dieters. Food energy is used by the body to promote growth, maintenance, and repair. The body thrives on carbohydrates, digestible fats called lipids, proteins, vitamins, and minerals, and water. Water makes up 60% of the food we eat and is considered a nutrient.
What is the food guide pyramid? Well, the food guide pyramid has replaced the 4 food groups. And what it is a visual explanation of what a well-balanced diet looks like. It really emphasizes moderation, variety, and balance. And it teaches us that the foundation of our diet should really be carbohydrates. And as we move up the pyramid, we have to also acknowledge we need to include fruits and vegetables, dairy foods and meat foods, and that fats can be used in moderation. Just because fats are at the top of the food guide pyramid doesn't mean that we should never eat them or eliminate them, but that they should be used in moderation.
Athletes certainly need a well-balanced diet to perform at their peak, but so do we all. Whether you're a student, mother, father, an office worker, or involved in heavy lifting, your body needs its supply of food-derived energy. Take a look at this list. It underscores the importance of a varied diet, complete with fruits and vegetables, grain products, milk products, and meat or meat alternatives.
When we're talking about weight control, we're really looking at the relationship between food intake and energy output. The food that your body takes in to use for energy is used throughout your whole system. But to prevent weight gain, you can also exercise. So physical activity is also important. Eating too many calories and not burning them off through physical activity will result in weight gain.
If you exercise even a moderate amount, your body's metabolic rate accelerates. Even small increases in exercise can dramatically increase the number of calories you consume. However, if you eat more calories than you burn, the excess calories will appear in the form of fat deposits. In extreme cases, it can result in a person becoming extremely overweight or obese, which carries with it a variety of potential health risks.
There are many health risks associated with obesity. Some of those include diabetes, heart disease, some forms of cancer, high blood pressure, just to name a few.
Obesity is just one of the disorders that is linked directly or indirectly to the digestive system. As Jason Hawkins reports, some of those conditions can be nothing more than uncomfortable nuisances, while others can be outright life-threatening.
We live in a world where young women are made to believe that thinner means better. From fashion to advertising to entertainment, it's a message delivered overtly and repeatedly. That psychological bombardment may be one of the principal reasons that young women are the primary victims of eating disorders. Though conditions like bulimia and anorexia nervosa typically affect young women, they also sometimes attack men, and attack is an accurate description. Bulimia is characterized by binge eating, followed by self-induced vomiting. Victims of anorexia are afflicted with appetite loss, even subconsciously impose starvation upon themselves. Both conditions can produce catastrophic results.
The side effects of anorexia nervosa include stopping menstrual periods, bone loss, potential for cardiac arrest or death from a heart stopping, failure to grow, loss of hair, loss of fingernails or brittle, very brittle fingernails, scaly skin, extremely cold feelings, inability to tolerate cold. The person's metabolic rate slows down and they really become very lethargic and very tired. For bulimia, the side effects include effects on the esophagus and the digestive tract, including potential tears in the esophagus, bleeding from the esophagus, breakage of the esophagus. The stomach can actually rupture open, leading to death. Another effect is effect on the potassium level, which is an important mineral in the body. The loss of potassium can lead to a heart attack or cardiac arrest where the individual may die. Another effect is that the teeth are affected by the acid from the stomach, and the acid from the stomach causes enamel to erode on the teeth.
While the gastrointestinal tract is a convoluted array of piping, some of the ailments which afflict its operation can be rather simple. Everything from tooth decay to gum disease can inhibit efficient digestion of food. Some conditions, like ulcers, can range in severity from uncomfortable to life-threatening. The consumption of acidic foods, or even extreme stress and anxiety, can increase the body's secretion of gastric juices, which in turn cause ulcers. Serious gastrointestinal conditions should not be ignored. Abdominal surgery, or endoscopy, is the typical answer for most other gastrointestinal conditions, including peritonitis. Peritonitis is an inflammation in the lining of the abdominal cavity caused by bacteria. Left untreated, the infection can cause death.
By peritonitis, we refer to a condition whereby the inside of the abdominal cavity becomes infected or inflamed. There are a number of different causes for this, and almost all of them require surgery to cure them.
In the case of tumors in the GI tract, early detection is the best line of defense. Choosing a diet high in fiber and low in fat can help reduce your risk of heart disease and cancer. What you consume provides the vital energy that fuels your entire body. Ultimately, a healthy digestive system is critical to a healthy body. This is Jason Hawkins reporting.
Food is metabolic fuel for your body. The unit of measure of this fuel is a kilocalorie. Your body needs carbohydrates, lipids, proteins, vitamins, minerals, and water to thrive. Your body also needs exercise. Exercise affects not only your metabolism, but also your quality of life. It is important to eat healthy foods and exercise regularly. However, an obsession with food can lead to life-threatening eating disorders such as anorexia and bulimia.
Every minute of every day, the Recovery Resource Center creates energy for use in lighting schools, offices, and homes by efficiently burning fuel. Your digestive system is as refined a resource recovery operation as was ever designed. It's your personal power plant, supplying your entire body and all its critical systems with the energy that sustains your life at work, school, and play. Thanks for joining us for The Human Body. I'm Mike Dowling.